Go!
Hello everyone, welcome to Practical GCP. Today I would like to talk about a scalable and yet cost-effective solution to back up data on your BigQuery projects. So this is the first thing I would like to talk about is why backing up BigQuery data is still important. So some of you would know the things like time travel that you can use in BigQuery, which I'll show you in a bit. But why is still important to back up the data from BigQuery? I'll talk a bit about that. And then we'll walk through the design of how to design the scalable and cost-effective solution. I'll walk through the architecture diagram. I'll show you the core components that you need to deploy to make this work. And of course, there is also going to be code walkthrough and then a demo of the whole solution working end to end. There will be code repositories for you to use the code as well, shared under the MIT license. Yeah, so feel free to grab it and then deploy your own solutions to make sure you have proper backups in place. Right, to start with the topic I mentioned about time travel. So if you don't know about this, you should know this. It's really important. Time travel is something that you can use with BigQuery. It basically goes back to up to 7 days, right? So any table you've got in basically anywhere, you can actually use something like this to actually go back to it. You can go back to the last hour. This is kind of accurate to the seconds of you can go back to 10 seconds, 20 seconds, or even up to 7 days. So it's very powerful. You can use the system time syntax to go backwards to find in the same table, but at a historical point for any point in the last 7 days to give you the snapshot at that point, right? And so this is a very powerful feature. So if you actually accidentally lost your data, even you deleted your table, you can still get it back. The syntax slightly different kind of on this page, show you later on below, but it basically gives you the solution to go back to whatever at the point of time you have in the last 7 days, right? But why do we still need to do a backup? So the time travel feature only works, right, if you actually deleted a table or changed a table. But what it doesn't work if you look at this section here. BigQuery has obviously a function for you to delete the data set, right? So this can happen by mistake, right? If you deploy something and somehow you manage to get rid of something and you can run the wrong statement, or someone could have got permissions to delete the data set. So pay attention to what Google said in there. If you have deleted the data set, this operation is permanent and then you cannot get your data back, right? This is serious stuff. So you do not want to lose your data forever. And if you actually have done this, I've seen people have done this, and then you lose it forever. You cannot get it back. So this is probably the #1 reason why you still need to back up your data on BigQuery, and then so you don't actually end up losing your data asset. And then a lot of this data these days, especially the ones that events based, once you pass that point, you cannot get it back, right? So make sure you don't lose them. So with that keep in mind, this is the reason I talk about cost effective is because in the old days, you can still use, you can just copy your data, right? There's a copy function of BigQuery. You can copy one table from one place to another and use that as your backup. You can, give that a time to live, and the table expires after a couple of days. You can do these kind of things. But one of the key problems is the storage cost. So you can see the snapshot solution is something that is quite new. I think it's been there probably for a year or so. The snapshot solution it works in a way that it only charge you the difference, right? So if you got a table, let's say it's a terabyte, and then within that table you make changes, you add data to on top of the table every day with daily partition on top of that, right? So when you do a snapshot, if your table doesn't change, right, your source table doesn't change, the storage cost is 0, right, in the snapshot. This is a really important thing because storage cost does that up, and then in a large organization you could be paying 10,000-20,000 pounds a month just on storage. If you actually do a backup of all of your tables by using copy or sending it to somewhere else, then it will easily double your storage cost, right? So this is really important. You figure out the deltas, and then you only get charged in a snapshot for the delta. So very, very important. The other thing is, sometimes you want to, let's say you can go time travel back to 7 days, right? But the data after 7 days, you cannot go back to anymore. But if I have a snapshot, right? So that snapshot, the data does not disappear, right? So you still can go back to more than the 7 days. So this is really, really important of the something that snapshot gives you, because it's a point in time, right? So even you go forward and then you don't have the data anymore in your latest versions, but it will still be in your snapshot. It obviously depends on how long you keep your snapshot for. So that is really important. So the snapshot capability that BigQuery offers is the cost-effective way of doing it. So let's say your data change like a little bit, especially the best practice using the BigQuery table, especially for ingestions. That's what is primarily used for. Then your historical data doesn't change, right? Because if you keep going back to your historical data, not using partitions, and keep changing your old data, then even without the snapshot, you're not going to be able to utilize the half of the storage cost feature that if you don't touch your historical data in BigQuery. So this fits into that really well. But obviously, if you change historical data from the very past, it can incur quite a large cost, and because the difference will be the way it's calculating difference is whether you touch the data or not, right? Not it's just you change one value, you think it's changed one thing in the past. But if you change even one tiny thing from the past, the snapshot can have a significant cost. So ideally, you don't want to touch your historical data at all. And then in this case, that your snapshot would only charge you the deltas, which is minimum in terms of cost. But the main purpose of backup, in my opinion, is to make sure these disasters don't happen, right? So if you have actually deleted a data set, it is very important that you have that snapshot for you to go back to. There's a number of limitations. You obviously can only create a snapshot on the same region, so that's kind of the important one. But for majority of organization, that is, you can't actually cross-reference table, you can't join between tables if they're in different regions anyways, so it kind of naturally makes sense. The snapshots read-only, you can't change them. That is actually a very good thing. It's a backup, right? You don't want to mess around with it. There are a few other things, like here this section explaining is actually quite well illustrated in a way. You can see your base table, it's got new data, right? And then the snapshot is basically only cost you the data that is in difference, right? So it's not actually cost you the whole thing. Yeah, that's pretty much how much I want to go through about the snapshot itself. So let's go into the solution itself. There's one last thing I want to talk about the snapshot is when you create a snapshot, you always and should give a TTL, right, time to live. So the snapshot expires after a period of time. So you can actually do your snapshot every day, right? And then you keep your snapshot for another day, right? Then you always have this backup for a day or so, or you can keep it for longer. But I would say, obviously, if the main purpose, in my opinion, is to stop the disasters, because you already have the 7 days on the other side with the time travel, so it's not necessarily useful to keep so many copies of it for the whatever the days in the snapshots. Okay, let's have a look at the design. So it is quite simple, really, but the design contains kind of two important parts. So the two kind of red bits. So the first one is there's two cloud functions involved, right, in the deployment. I'll go through the whole thing end to end later on, but let's start by looking at the two key components that we need in this design. So the first thing is to find the tables that you scan the tables that you want to do the backup, right? So this is basically the function. You find all of the tables you need, right, to do the backup in any particular project or multiple projects. And then the second part is about triggering the backup. the reason I've actually split the two rather than do it together, imagine you can use a cloud function to go through all of the tables you need to back up, right? And then you do them one at a time, sequentially. It's just, that might take a very long time, right? The much better way to do it, or the much easier way to do it, is where it comes down to the scalability part. So the way I've designed this is you basically find all of the tables you need to back up, right? And then including the project ID, the dataset ID, then you send a message payload. You publish the table names alongside with other metadata information of the table into a PubSub topic, right? This is why I call it the trigger backup topic. So so each one of those events, will trigger a independent cloud function that will do the backup. So if you have 100 tables or 10,000 tables in here, it will trigger these 10,000 times, right? So each of these will run independently, doing the backups and then creating the snapshot. So all it does is I'll show you the query later on. It's basically a very simple query to take the snapshot from the source project or multiple source projects into the backup project. So the backup areas where you store your data, I would not recommend you store the backups in the same place where your original data is, right? So I would say always store them in a separate project, and you can consolidate all of these in the same project. I'll show you a convention you can use later on to make sure there's no clashes with the names. But because if you store it in a separate project, let's say the backup project, right, you can lock the permissions away, right? So no one can actually, there's very limited amount of people can actually see this on its read-only as well. You don't want people to be able to delete it. If you actually store in the same place, it's quite difficult to manage permission. And if someone made a mistake, you might actually end up losing both, right? So it's always to lock these away. Very important. Okay, so let's have a look at the whole thing from the beginning to the end. The whole thing gets triggered by the cloud scheduler service. So this is just a Google service that very simple that you can trigger a message that be sent to PubSub, right? One of the important things I want to mention here is the use of PubSub with Cloud Scheduler and Cloud Functions. So the reason for this is that there is a native integration between Cloud Scheduler, so you can send directly to PubSub, right? And then using the Google SDK all privately, and then using the PubSub would then trigger the Cloud Function again privately using the PubSub integration. So it's not like something like an HTTPS endpoint you need to set up, because as soon as you start setting up HTTPS, you need to involve, like the all of that public endpoint you need to manage yourself, which is much less secure, right? So in this case, the whole thing triggered by PubSub into Cloud Function, then you send something to PubSub again, that's private again, and then here the trigger is all again private. So there's no HTTPS endpoint involved for you to set up. It's all done natively by the Cloud Function integration with PubSub or the integration from Cloud Scheduler, right? So this design is based on you trigger the Cloud Scheduler maybe 1 a.m. in your local time zone every morning, right? And then this just fires up like an empty payload to the Cloud Function, which the first one will do the scan, whatever projects, data sets you want to back up, that is the base tables, because you can't back up views, right, or materialized views or any other stuff, and then it's no point either because the original data is in the base table. Then each of these is going to be a single message, which will subsequently trigger the Cloud Function, does the backup job, which creates the snapshot, right? So this is kind of the design. There's a few moving parts, but don't worry, I've got a source code for you, so you can just quite easily just look through this yourself and then deploy it. And the scalability part in here is important, because if you go through this, as I mentioned earlier, one by one, if you have 10,000 tables to back up, it could take ages and then it could fail. It's really difficult to manage the how to run the backup itself. But if you use the message queues, it will take like just a few seconds. All of your instruction to what to back up is going to be in this PubSub topic, and then it will trigger independent Cloud Functions to back them up later on, right? This is much more scalable, and then you can easily back up loads of things within a couple of minutes, right? So that's really important. Okay, let's look at the code walkthrough. So I've I've uploaded this to the solution into the BigQuery backup snapshot automation repository, which is public, and I will put it in the video description in a bit. So as you can see, this has the two parts, right? So it's the scan part is where it gets the table information to be backed up, and then the trigger part is to trigger the actual backup. So let's have a quick look at the code itself. So I'll give you like a high level overview, so you can actually dive into the details later on, because with you already have an understanding of the architecture and design, so it should be quite easily to just jump into code. So this part, there's few details important in here. Is the scan part is it uses the information schema meta table to find all of the base tables that are required to be backed up. So the way I've done it, if you look at the source code here, is based on the region. So if you look at this part, so this is the main query that is most important, and then you can specify, in this case I've specified a number of projects to scan, and then you go through this, and all you have to do is define the project ID, the dataset ID, and the table ID, right? So that you can get from the information schema tables, because even you have multiple different sections of different countries and regions, it kind of makes sense to kind of start with one region at a time. So you pick a project, you pick everything from that region, and you do your backup, right? And that gives you all of the tables from that project of that single region, rather than going through in the dataset, which is quite clunky. And then all it does in here, you can see, is just to compile the message here and then send it to, you got the source project dataset table ID and the target project dataset table ID. So this has all of the information that the second cloud function that we'll need in order to action on the backup itself, right? So it's quite straightforward, and then there's a bunch of functions you've probably seen from the previous videos on how to reliably send PubSub messages, but it's the same thing, right? Few environment variables to set up is all in the README itself. And obviously you need to set up the topic to do the backup for the backup subscriber, and which is the one that required to keep all of these, the messages in there for the second cloud function to pick up. And then obviously you would need the schedule scan for backups topic, which is the one that integrates with the cloud scheduler to trigger the jobs once a day. And this is the way you can deploy it. I've got the environment variable set up there for you already, so you can just hook this up with your CI/CD pipeline and replace with the things that you need in here, right? So the backup project, if you need one, you can just put one in there. If you need multiple, split it by comma, right? That's how it works. And then here, all the environment variables are set and triggered into the deployment. The second part is the trigger. So this is where we integrate the cloud function. As you can see, this is the built-in integration that you can integrate the cloud function with PubSub natively without defining any of your endpoint. This is really powerful. And then because of this, you can just subscribe to the topic directly, and then you should also add retries, because if something does break, then you make sure it does do the retries, right? Especially because if I go back to the previous one just a little bit, you can see that one of the things I set in here is the message limit in how many I want to send at a particular time, because there's a quota of 50 concurrent snapshot queries you can run at a single time. So but if in any case you hit the quotas, it will basically throw an exception that back into the message in the topic would be retrying, right? So but if you don't turn on the retry, then you would literally lose that backup. So that's not ideal. That's why you want to turn on the retry as well, with the trigger part. So let's have a look at the code very quickly in there. So you've got a number of kind of utility functions that get in the client. There's a function to create the data set, because this is like a fully automated solution. So if your data set in the target backup project does not exist, it will look at it and then create it in an automated way. I've set the exist OK to be true, when you create a data set, what this means is if your data set already exists, it would not raise an error, right? You just say it's already there, it's okay, but it doesn't have to fail it. So the second cloud function is designed to be idempotent. There's a few other things I need to show you that is important. Why is that important? But you basically don't want it to fail if there's not a very good reason to fail, right? It will just carry on. And then if it data set is there, you don't want to say, oh, sorry, I can't create a data set. You just say, okay, fine. Then we're now going to do the backup, right? So this is the key thing, that it uses all of this source and target table information for the backup to build your query. And this query is the key. I'll talk through it very quickly. You've got a few things in there that's important. You've got the snapshot time, snapshot name. As you can see here, so I've used the target project ID and the target dataset ID and the target table ID with underscore of the date and time, right? This is important because when you do the backup, it will actually send the backup, in this case, to a different project. And then when you have a prefix, you can actually use the kind of when you have a suffix, you can use the suffix-based partitions. You can see it's much nicer organized, right? And also, again, you can't override the snapshot, and that's not a good idea either. You always want to kind of create a new one and leave the previous one alone, okay? And then the last thing in here is basically saying creating a snapshot table using the snapshot name, right? And then clone it from the source, right? This is from the source with the option. This is where you specify your TTL, right? Time to live. I've set this to 1 day from now. So because I don't really want to keep it longer than required, but if you want to keep it for a few days, that's fine too, right? So, but keep in mind, it's not going to really cost you on the storage cost on the whole source table. It's only going to cost you the difference, right? So this is the actual thing that does the backup. So you can see this is the cloud function convention that's going to trigger this backup table with the event that's coming from PubSub, right? So in here, you've got this data set check. So if it exists, you'll create it. If it doesn't exist, it'll create it. Otherwise, you ignore it, right? And then in here, it compiles the query to do your backup. And then finally, you will do your backup, right? So there's a few things in here that is quite important. So I've done some exception catching and handling in here. So when you try to do this, right, there's a bunch of things that can happen, and it can also kind of give you this bad requests and errors and things like that. So what I've done in here is I've checked what the error is from the message, even if it's the same type of error, and I want to skip it if it doesn't make sense to stop the execution or to report an error. There's two scenarios. One is if the backup already exists, right? So if the backup already exists, that means I'm trying to, maybe your schedule is set to run too often. I'll try to replace it for whatever reason, right? And then that is not a good idea. And then because it already exists, then I just don't want to do anything with it, right? That's one thing. In the other case is when you kind of point to, it depends on the kind of your permission setup. In the other case, it can fail is it try to kind of delete the snapshot, right? If you try to delete the snapshot in this design, and you should not give it permission to be able to delete the snapshot. That's not a good idea, right? It should always just be creating new snapshot and then let the old one expire, but it should not have permissions. So if you hit any of these issues, you can log it as a warning, but you don't actually want to do anything about it because the target snapshot is already exist, right? So it means the code is trying to do something that should not do, but is safe to ignore. In any other scenarios, it means there's an error, right? And that means there's a problem with the code, and then you need to raise an exception and then stop it. But so far, because for the solution I've tested, there isn't a other scenario. So, but it's just what I'm trying to say. If there is another one, I want to know about it rather than hiding it, right? Because otherwise my table is not backed up. Okay, that's pretty much the whole thing, right? So the last bit is about restoring the table. This is really straightforward. So I'll just include this in the repo, and then you can have a look at it. You can use the SQL part, you can use the BigQuery command, but basically you can restore it to a new table from the snapshot, or you can restore and then force replace the existing table that you already have, which could have been truncated and you lost the previous version, whatever that was, right? So this is how you can restore the data. So this gives you the whole end-to-end package, right, for the whole solution. Right, now let's have a look at the demo. So what I've done is, you've probably seen this this project before. This is what I used for all of the previous videos. I've got a bunch of tables here, the different sizes and different kind of things, right? That's the project I'm using as my source to be backed up. Right now I don't have any backups. You can see this is my backup project. This is empty, right? There's nothing here. So I've deployed the two topics. One is for the schedules, and then one is for the backup part, right? To actually trigger those backups. I've deployed a cloud scheduler in here to basically send the basically all I did was I sent the empty payload as in the message, because it just needs something to trigger that function, right? I don't have to care what's in the message. It just needs something to trigger it. And then finally, I've got the two cloud functions. One is do the scan, and the other one is to do the triggering the backup. Okay, so that's all of these things in place. Right, so this one, I've tried to run it before already, but now because I've deleted all of the things being backed up, so I can show you what it looks like. Currently, it's set to run at 1 a.m. In Europe, London time zone every morning. Right now, because I don't have anything, I'm just gonna trigger a false run. So now this is gonna send a message to the first one, right? Okay. So let's have a look at so that's been triggered, right? So on the other side, it should trigger the scan, right? So now it's like looking at, you see, this was kind of when I was testing like in the morning, but this is right now, right? This is kind of triggering all of the scans, right? It looked through all of the things that need to be backed up, all of the base tables, then it sent this message. See, you've got the project ID, the dataset ID, the table ID, and then the target, which goes to the backup, and then you've got the this is the important thing that I want to mention here. You can see the payload here is a concatenation of the the dataset ID is the concatenation of the source project ID and the dataset itself, right? So this is to avoid you having some kind of a naming conflict, but just in case you have multiple projects and then the dataset is called exactly the same, right, and a table to call exactly the same, you're not going to have a conflict in this case. So the dataset name, you can have just about 1,000 characters. So I've not in my life seen anyone has that kind of a long name, including the project ID itself. So it should be fine, but just watch out if you happen to have really long dataset names for whatever reason, then this may not work. You might have to truncate it to the closest length, which is I think is 1024 bytes, right? So now you can see all of these are sent. So I've actually waited for all of the messages to be sent. If you look at the second function, which is to do the backups, right? So now the backups here, you can see as of now, these look, that's all started at around 231, right? And then within it's all kind of finished within a few seconds, right? This is how good the solution is. You can see it's all done it, right? This has all happened. And now if I go back to the backup and refresh this page, let's see what happens. Look, I've got all of these convention project based, and then with the snapshots. Look. So the underscore with the second part, because you can see this is 1, right? You got a 1, which means it's got 1 snapshot. So when you got 2 with different date and time, then it's all kind of stored within here. You can see this is like a 20, 22, 06, 26, right? And then it's the snapshot. Yeah. So that's it, right? I want to show you also before I wrap up, the important thing about the idempotency if I actually manage to trigger something again, right? So what I can do right now is I can trigger this schedule again, right? So if you look at the backup, so it should come through in a second. If I refresh the logs, right? You see all of these coming through, and then 1435, the function is started, right? You can see I'm just logged in these as warnings, right? You can see because these already exist, I don't need them to fail anything. So all of the logs is basically saying, don't worry about it, I already got the backup, right? That's what it's saying. And then in the target place, you can see I still have 1 copy. It's not trying to mess around and creating like 1 million copies if you run your functions really frequently. Yeah, there you go. You can see, and then everything is back up here, right? So all of the data sets from the source projects. Yeah, makes sense. Cool. Right, that's it. This is the solution, and again, source code is here made available to you that you can use and adapt it to your own use cases. It should be quite robust already, as you can see. It works end to end, and so has the deployment is really simple as well. There's not much kind of involved in here other than yeah, just implement the solution and make sure you have the backups you need and not lose data permanently. Okay, that's the end of the session, and thank you very much for watching. See you next time.
Go out!